project planning, scheduling and critical path analysis. Now for critical path analysis, we may need to go from a weighted activity table with predecessors to an activity network and then do forward and backward scanning to identify the critical path. We could start just with this. I have given you the starting point for this activity network just to speed things up a bit. So making an activity network, we've got A, B and C which have no immediate predecessors, so they'll come straight off the start. A has a weighting of 3 weeks, B has a weighting of 5 weeks, C has a weighting of 12 weeks. Now you don't need to make the lengths indicative of the length of time. You see I've made 12 longer than 5, which is longer than 3, but it can help to make things a little bit clearer. Now D and E both have A as an immediate predecessor, so D and E will come off that. D is 4, E is 7. Next up, B and D are both immediate predecessors for F. There's no double up here, so we don't need any dummies. This is F with a length of 5. G required E and F, and G had a length of 6 weeks, and H required a predecessor of C. Oops, I forgot some arrows here. H had a length of 2 weeks. So that's our activity network, and remember we put 2 boxes or 1 box with 2 zones at each vertex. We'll do forward scanning in our yellow box, and the first box there gets our earliest start time. So we always start with 0, and remember we need to look at both ways that we could get to any particular vertex. There's only one way of getting to A, so 0 plus 3 means that the earliest we can start these next two is at 3 weeks into the project. Then C is nice and easy, 0 plus 12 weeks. So the earliest I can finish C and start on the next one is at 12 weeks into the project. Now here I have 2 paths coming in, one from D and one from B. So I have to take the longest option. This is 5 weeks, but this is 3 plus 4 is 7 weeks. So since I need both B and D to be finished before I can start F, 7 weeks is the earliest that I can start F. So this is the earliest starting time for the activity following. Again, I've got 2 paths here to get to this vertex. 3 plus 7 is 10. 7 plus 5 is 12. So 12 weeks is the earliest that I can start G. So we take the largest possible number going on. And then 12 weeks plus 6 weeks is 18. 12 plus 2 is 14. We take the largest one, which is 18. So our project will take 18 weeks if there's no delays. Then backwards scanning. So the latest starting time, we always start at our 18 there and work our way backwards. So 18 minus 2 is 16, telling me that my earliest starting time for H is 12 weeks in, but the latest I can start is 16 weeks in. And remember that float time, the amount of flexibility we've got, is the latest starting time minus the earliest starting time. So I've got float time for the starting point of H of 4 weeks, where we can be a bit flexible and there won't be a delay to the overall project. So that we've got back to H. Let's get back to the start of G. I have 18 minus 6 is 12. Working our way back, 12 minus 5 gets me to 7 there. Now, there's two ways that we could come in to this vertex. It could be this way or this way, and we take the smaller number this time. So 12 minus 7 would give me 5. 7 minus 4 would give me 3. So that's saying I can't delay starting at this point because both of these need to be done pretty promptly. And then we always, 3 minus 3, we go back to 0 here. We could track back and say, well, 7 minus 5 is 2, or 16 minus 12 is 4, but 3 minus 3 is 0. We always take the smallest one when we're backwards scanning. So we've done our activity network with forward and backwards scanning. And we've got some questions. What is the critical path? Now, the critical path obviously goes through all the vertices where the numbers for earliest and latest starting time are the same, because that's going through all the vertices where there's no possible float time, and that tells us how long, where things might go wrong. So up here, now don't be tempted to zip down here because I've got to include this vertex as well. So it can be a good idea just to highlight your vertices and then say, okay, that means we're going here, here, and here. And if they say, what is the critical path, then we list the activities. So it's A, D, F, G. That is our critical path. What's the earliest starting time for activity E? That is earliest starting time at the start of activity E, yellow box, 3 weeks in. The latest starting time for activity E now, it is, when we've got these two here, because this 3 this 3 refers to, that's the latest we can start anything at this vertex. You can check activity E's on its own because it's not part of the critical path. It's going to have some flex time. So 12 is our latest starting time that we can be at here. Take away 7 brings us down to 5. So activity E, even though it's not quite clear from this, does have some flex time. So the latest starting time is 5 weeks into the project. Sorry, I'm getting a little bit messy there. Now remember that float is latest starting time minus earliest starting time. So I've got a 2-week float available for activity E. Oh, my writing's so messy, I'm sorry. Now, the person completing task E will be away until the 5th week of the project. Will this delay the project? It won't. Even though we see a 3 here, that's indicating it's for D. We've checked that there's some float time on E. So, no, because latest starting time for E is 5 weeks. So as long as they're back until the 5th week, everything's okay. So that is critical path analysis.